a subset. So when we are trying to generate a subset, if you closely see, the subsets can be starting with index 0, can be starting with index 1, or can be starting with index 2. It means when you are at initial phase, you have three possibilities. Either you start with index 0, or you can start with index 1, or you can start with index 2. So you have three possibilities. Let's see how can you do that. Let's say I want to start with index 0. Okay, so I want to start with index 0. If I start with index 0, so whatever carry forward you are taking, so this is your current subset result which is forwarded here. So earlier it was empty subset. You are starting with index 0, so that first you take the index 0 value. So index 0 value is 1, so 1 is been taken. Now you move on to next possible solutions. So I am trying to move on to the next possible solutions. So from index 0 I can move either index 1 or index 2. That's how the subset works, right? If you closely see, this is index 0. So from index 0 I am moving to index 1. If I move to index 1, I get 1 comma 2. If I move to directly index 2, so I get 1 comma 3. So it means from index 0 you can move to index 1 or index 2. So see the how recursive stack is working. So this is first call and this is our second call. And from the second call you have two possibilities. From index 0 I just take the index 0 value to the subset. From index 0 I can move to index 1 or index 2. Let's say I choose this as a third call, so I move on to index 1. So when I move on to index 1, so what is your thing is whatever subset you are carry forwarding. So what you do, you take your recursion method will take two values. One is index, another one is subset. So this is index and this is subset. So when you choose index 1, so to this subset you will add index 1 value. Index 1 value is 2, so that you just add 1 comma 2. Done. Now from index 1 I can have only one possibility. From index 1 you can only move to index 2, so that I can move on to index 2. Okay, so this is my fourth recursive call. At index 2, whatever value you have, so the value you have is 3, so you just add to the current subset, so it becomes 1 comma 2 comma 3. Now if you closely see, let's assume this is your recursive stack. At this point in time only these four stack frames are active. So these four stack frames are active. Remaining possibilities we didn't explore the remaining possibilities, so we explored only following these stack frames. If you closely see, first we are trying to starting with empty subset, and from empty subset, so we have three possibilities. Either I can start with index 0 or index 1 or index 2. So I am exploring the possibility of index 0. So whenever exploring, so first you take that value to the subset and move on to the next indexes. So from this index you move on to the next index. So the next indexes can be 1 or can be 2. So I am first exploring the possibility of index 1. So when you are exploring this possibility, whatever subset you got, for that subset you just add the value 2. And from there, from index 1 you can move on to index 2, because you still have indexes 2. From index 1 you can traverse to index 2. So that I just take that index 2. For the previous subset I add value, current value, so which is going to be 1 2 3. So if you closely see, at each recursive call you acquired all the subsets starting with 1. Yes or no? Whatever subsets I traverse till now, all these subsets are happening at each recursive call. I am starting with index 0, so that I found out all the subsets starting with index 0. Yes or no? Yes or no? Is this clear? So we found all subsets starting with index 0, right? Now, now closely observe. We are manipulating with same. Assume that this is a temp variable called list of strings. So list of integers. We are manipulating same subset, right? So we are manipulating same subset throughout the recursive call. So from here empty subset becomes 1, and it becomes 1 comma 2, and it becomes 1 comma 2 comma 3. So in a backtracking, right, so what happens in any backtracking problem, you take one temp result. So one temp result, so you can take one temp result, it can flow on to the complete recursive stack. It can flow onto the complete recursive stack. At each recursive call you can acquire a result. So in this case, for this use case, at each recursive call you can acquire a result. that result will be stored into our actual variable. For example, I will consider a result called list of integers. So what this is going to hold, this is my result, this is my result. So in backtracking, what we do is, first we start from empty subset. So first I will store that empty subset to the result variable. Then I'll explore the next possibility. Next possibilities, there are three possibilities: 0, 1, 2. So first I go to 0. At 0 you have, for this empty subset, what you did, you added value 1. So I store that value into the result. Okay, so I store that value 1 into the result because this is a variable which is flowing across the recursive stack. This data keep on updating, this data keep on updating, so that for safe side I will store that value into the result. Then from index 0 you can traverse either index 1 or index 2. So I am trying to traverse into index 1. So when I am trying to index 1, I updated current list to 1 comma 2 because I added the index 1 value, so that it becomes 1 comma 2. I just holded that result into my result variable. Again from index 1 you traverse to index 2. So whatever current list you have, for that list I added one more value, so which becomes 1 comma 2 comma 3. So it means I holded all these values into the result. If you closely see, by this I have solved I have solved one direction of subsets starting with 1. So this direction of subsets I have solved one direction of subset starting with index 0. I want to explore other direction. If you closely see, this is what we did. So with index 0 we have done with one direction. We need to explore other direction. To explore other direction, if you closely observe, we have already corrupted the current list. Whatever list you are trying to pass throughout the recursive stack, that list has already been updated. That's why this is very critical point whenever you do backtrack. So this is where you do backtrack. So I'm trying to backtrack from here. So means from index 2 I don't have any possibilities to explore, so that I am backtracking to the previous call stack. Whenever I am backtracking, the more importantly you need to understand, so this is your current result which is traversing over the call stack. So what you do, whatever last value you have, you just need to delete that last value and do backtrack. So once you backtrack from index 2 to index 1, so this, once you delete the last value, once you delete the last value, let's closely see, this is the value, right? This is the value which is been added at index 2. So we delete that last value from this current list. You move on to the previous call stack, again you get the same result, again you get the same result. So if you closely observe, when I start from index 1, this is the result I acquired. So that from the bottom, when I'm reversing to, when I'm going back to the top, I need to remove the last value so that I can get the same result, 1 comma 2. Now again from 1 we have seen possibility of 2, so there is no other possibilities. From index 1 you hardly go on to the index 2, there are no other possibilities, so that I need to backtrack. So I am trying to moving on to its caller. The caller is index 0. Whenever I am moving on to the caller, so we already disturbed this current list, right? So just delete the last element from the current list, you again get the same value. So from index 0 you have value 1, right? The same value. It means whatever values we updated, so we are trying to remove from this current list. This current list is something which is traversing over the call stack. So now done. So with index 0 we have seen possibilities of, from index 0 we traverse towards index 1, then index 2 we got these results. These results we already cached into the result, actual result object. Then from index 0 we have seen possibilities of index 1. Let's see the possibilities of index 2. Let's say what happens if you move on to index 2. Okay, so let's do that. Okay, so from index 0 you are moving on to index 2. What you do is, whatever current list you are having, so this is current list, right? The current list is having 1. Whenever you are looking at the possibility, if it is a valid solution for index 2, whatever value you present at index 2, you just add to the current list, so that it becomes 1 comma 3. As and when you get it, so you just add that result to, you just copy that result into result variable. Then if you closely see from index 2 you can't move further, so it's time to backtrack. So whenever you are doing backtrack, you already disturb the current list which is been passed to the current recursive call, so you need to remove the last element so that you will get the same list which is present at the caller. So this is caller, so the caller is calling index 2. So while index 0 calling index 2, the value is 1, but when it comes to index 2 it updated to 1 comma 3, so that first we deleted, whenever we are backtracking, so we delete the last element, you get the same value. Now if you closely see, from index 0 we have seen all possibilities, it's time to move on to its caller. So whenever you are moving on to its caller, just remove the last element from the list. So in the list you have only one element. Once you delete, again you get empty subset. Now if you closely see, we have explored all possibilities with respect to index 0. Do you understand, please? Everybody understood this flow, or any questions? Yes, we have to do that, right? Because that is what the list which is been keep on updating. So in any I'll tell you what are the steps to follow in backtracking, but first algorithm, understood the algorithm. Now let's move on. Now you are trying to see the possibility of index 1. So when you see the possibility of index 1, what is your job first? What is the value you have at index 1? First you add that value to the current list. So this current list was empty, so you added current value, so which is 2. Perfect. So you added value 2. Now from index 1, where do you follow? So you can traverse to index 2, because that is only the possibility you could see. So then you just add the value of index 2, it becomes 2 comma 3. Again you need to backtrack, right? So when you are trying to backtrack, so what you do, you remove the last element. So each time whenever you, don't forget this, for each time you store the temp result into this result, actual result variable. Okay, so whenever you backtrack, so obviously you remove the last element, you will get this one. Again you, it's time to backtrack. So whenever you are backtracking, you remove this last element, again you get empty subset. Now we see all possibilities starting with index 0 and index 1. It's time to move on to index 2. So when you move on to index 2, so what you should do, you just need to take that value, whatever value which is present, 3. So you just copy that 3 to the result. Then there are no possibilities to look into. So what you can do, you can backtrack, but before backtrack, remove the last element from the list. So you just do backtrack, you got it. Now you see there are no other possibilities. By this, then you already copied all the possible subsets into the result, so you just return that result, right? Is this clear? Is this clear? Okay. Now, can you tell me, before gets into the time complexity and space complexity, can you tell me uh, what are the what my recursive calls takes? Okay, first tell me what my recursive call takes. So each recursive call input, what is the input of each recursive call, please? So if you closely see, what is the input of each recursive call? What it does take, please? Yeah, so if you closely see, so this our recursive call will take definitely index, right? It needs index, where to start, right? Yes or nobody? It needs an index now, please. Yes or nobody, please? It needs index, and it also needs a given input array. So that is our nums. You can say it as an input array, and it also needs a current list. It also needs current list, and we can take as a result as a global variable. We'll just handle through it. So index is means this one. Nums of array means you take the value from nums of array, and current list is means this bracket is representing current list. Okay, now you understood what our recursive call takes. Now can you tell me how do you write a logic? So let's take, I'll just take list of integers. this is my result. Okay, so assume that this is my result. So I know that I am trying to derive a recursive logic here. So this is public void backtrack. This is very clear. If you understand this problem, right, I think you can solve next problems with simple way. So one way is I need index. Okay, I need index. Then I need a current list. This is what I am holding the values of subsets. Okay, then I need integer array input. Okay, now if you closely see, right, this is where you need to do that. So this is your result you declared as a local variable. So what you do first, when you make this call, when you make this backtrack call, how do you call, tell me? First, when you make this backtrack call should be invoked from somewhere else, right? Yes or no, please? This should be invoked from somewhere else, right? How do you call it, please? This is your custom method, nobody. You are going to invoke this call, right? From which index you will call? Perfect, right? So first you, how do you initiate the backtrack call? So you initiate a backtrack call with index 0, then okay, you can take a empty list, okay, and then give an input given input, right? So what is happening? So first you see the possibility from index 0, right? So that is more important. So this is what happens, right? First we seen the possibilities from, so from empty list we have seen the possibilities from index 0, then we have seen possibilities from index 1, index 2. So that's how it happens. Let's see. So whenever you gets into the backtrack, right, first you keep the current result. So the current result, if you closely see here, the current result is empty list. Every backtrack call is going to return a result. If you closely observe, this is here you are starting the backtracking call. So you are starting backtracking call with index 0 with empty list, right? Then what is happening? So you start from backtrack call with index 0 and empty list. So you hold this result into the, you hold that whatever list you acquire, you hold that into result, then initiate a backtrack call to the next subsequent calls. So this is where this is more important. So if you closely observe, this is what happened, right? Why? Why and why? What do you mean backtrack means? It is an, it's not a, it's not like terminology. So we want to solve the solution, right? So it is a subset always starting from index 0 now. We want to generate subsets, right? No, no, this is input, right? This is input. This is not current list, na. This is input array. This is input array, right? Right, right. Now, at this point in time, my result is empty, right? And my current list also empty. Where do you get 1, 2, 3? Where is the first list? This is input. This is not first list. This is input array nums. We have to traverse from here, right? From here only you will move on to here. We should start from here, right? So without starting from here, how can you traverse here? That's what we are doing, right? First we are starting from index 0 with empty list, correct? So this is index 0 and current list. This is our call stack. So we are starting from here. Now let's move on. So you are starting from here. So whatever result you acquire, store that result into the your result object. So you have result dot add. You can copy this current list. So you can clone it. New array list of this current list. You clone it. Okay, so you cloned it. Once you clone it, what should I do? Tell me. So what I did, so I clone whatever result I get. So in each recursive call you get a result, right? So whatever result you get, you just clone it. So I just cloned it. Once I clone to that into result, what is the next step to do? Tell me. So this is very critical. Move ahead. How do I move ahead? If you closely see, yes, we did. We added current result into current list item to the result. Okay, so this step is done. Next, I need to, this step is done. So next, what should I do? I need to move on to the subsequent calls, right? I need to explore all possibilities now. Yes or no, please? So this exploring of possibilities, from where it will start? Tell me. Means I need to call the backtrack. So yeah, so it should start all possibilities. The possibilities, one thing is for sure, if I write the logic, right, 1 minute, if I write the logic, you will get it, but you can't remember it. So when you understand the algorithm, better try to analyze it. If you closely see, I started from index 0 comma empty subset. So I need to see all possibilities. So when I'm looking with all possibilities, where the possibility is starting from? Tell me, where the possible. So index 0, right? So index 0. So the index 0 means this value only, na? So whatever caller call, if you closely see, index 0 means whatever caller index you have. So from there it is going to start. So now let me do that. Let me do that. So what I'm trying to do, this is my for loop. So I'm trying start. This is my start, which is starting from index, which is starting from index. Then this my start is less than nums dot length, then start plus plus. Okay, so what is the next step I am doing? If you closely see, what is the next step I did, please? Once I move here, what is the next step I did, please tell me? Yeah, before that, what should I do? Tell me, please. Before calling next backtrack, so once I reach here, I call the next backtrack call. But before that, what should I do? Tell me. Yeah, so we need to add the current result to the list. So which is more important? So in every backtrack call, you hold the value, right? So this is my current list now. So this is my current list. To the current list, I am adding whatever the value I hold, nums of start. Then I am going to initiate a backtrack call. Now be careful. How do you make a backtrack call? So what is the value you are trying to pass on for to backtrack call? If you closely see, from index 0, I am exploring only one possibility. So first I came here. So initially the start index starting from 0. From 0, I just added 1. So I need to make a backtrack call. So what should I do? Tell me. Next possibility. Backtrack call. So but what should I do? This backtrack call, right? So what should I do? All these should be in. No. That will take care, right? Once you make a backtrack call, again the same will come on, right? Backtrack call. To this backtrack call, what is the value, index value to be passed? Perfect, right? So it's a start plus 1, right? So if you closely see, when you start from 0, so you are trying to do 0, 1, 2, right? But when you start with this, you see in all possibilities, it means ideally it is 0. So when you come here, so whatever previous call you have, plus 1, right? So plus 1 onwards, all the backtrack calls will take care. So means from index 0, you will move on to index 1. From index 1, you will move on to index 2. So what you should do whenever you make a backtrack call, obviously what you should do, whatever start you have, for the start you just add plus 1. That's it. Once you add plus 1, there is no change in current list and there is no change in nums. Perfect. So what it does now, you tell me. So obviously what you are trying to do, again what will happen? So there is a backtrack call. So this highlight, right? If you closely see this part, So what you are trying to do, you are starting from index 1 and value 1. So again this is going to start with same cycle will continue. Closely don't, please don't confuse, same cycle will continue. If you closely see, now here 1 will come, so our start index becomes 1, so 1 less than or equal to 2. Now again you add one value, so that one value means 1 comma 2. Earlier it is 1, so you added 2. So again you initiate a backtrack call to 2. So again you initiate a backtrack call to start plus 1, so that what will happen, start plus mean earlier start is 1, so you added start plus 1 means 2. So if you closely see, the current index becomes 2 and the current list becomes 1 comma 2. Now 1 comma 2 is added to the list, then you have 2 here, so 2 less than 3. Now again it already 1 comma 2 was there, then you added current value 3, so that 3 will happen. Then it is calling 2 plus 1, so 2 plus 1 means 3. It will go 3 here. When it goes 3 here in the list, you already have 1 comma 2 comma 3, so 1 comma 2 comma 3 added to the list, but start becomes 3, 3 less than 3, so which is failed, so that it doesn't move forward. So what will happen, once from 2 you call 3, right? So 2 from start index 2 you call 3, and you added the result, it came back here, so there is no possibilities look into, so that it came back. Now this is where you need to take the steps, right? So from 2 you call 3, so when it is 3, so 3 less than 3 possibility was not there, so that it came out of the block, so it comes to the caller. So this is what happened, right? So from 2 ideally you call 3, but there is no possibility, so it comes to the caller. So from 2 there is no possibility to explore, so it's time to backtrack. So whenever you are backtracking from the current list, you remove the last element, so which is 3, right? How do you remove the last element from the current list? Are you confusing, man? Yes, right. So this is our current list. You remove the last element. So current list dot whatever value print you have. So size minus 1. That's it. So let me write it. Hope you get this. Uh, if you are confused, let me know. So you remove the last element. Uh, Clear? That's it, man. This is our complete backtracking logic. So let me explain. You already seen the code, right? So you already seen the code. Let me now let me flow to the diagram once again. This is our input array nums. You have values 1, 2, 3 with index 0, 1, 2. So what are we doing now? First, we are initiating. I'll just write as a backtrack. So with index 0 with empty list. Okay, and I'm just not copying the nums here. Let it be. So what you did, so you are trying to see all possibilities. So starting from this index, so that you see the possibility of index 0, possibility of index 1, possibility of index 2. So what you did, so this is your empty subset, right? So first you copy that value. First you see the possibility of index 0, so you copy that value, index 0 value, which is 1. Now you are trying to initiate a possibilities, right? What you are trying to do, if you closely see, this is the backtrack call you are trying to initiate. So what you are trying to do, you are trying to going on to the next index with the value 1, right? So with the value 1, so this is our backtrack call. Now from here it is going to see the possibilities, so it is starting from whatever index which is coming from here, so which is index 1, and it also see the possibility of index 2. So now when you are at index 1, first what you do, you add the value to this current list 1 comma 2. So this current list is 1, so you added index 1 value, so 2 is also added. Now it's time to explore the backtrack call. Now you are trying to initiate a backtrack call with this index plus 1, so which means 1 plus 1 2 comma current value, which is 1 comma 2. Now if you closely see, once you are here, so you are trying to see the possibilities. So blindly what you do, you take the current index, so which is index 2. So at index 2 you have value 3, so first you add value 3 to this, so it becomes 1 2 3. So you got 1 2 3. Now again you are trying to initiate a backtrack call. So ideally you are trying to initiate a backtrack call. So whenever you initiate a backtrack call, you increment by value, so index value by 1, so 3 comma 1 2 3. So this is what you did. But if you see that this 3 is less, not less than num, so that it just goes back, there is no process. From index 1 index 2 you've seen all possibilities, it's time to return to the caller. So if you closely see, this is our caller, it's time to return to the caller. So in order to return to the caller, this caller, right, this caller initiated this call. Hope don't get confused, this caller initiated this call by updating the index by 1, right? So while returning to the caller, you need to remove the last element. So that is what we are doing. So while returning to the caller, we need to remove the last element. So that is what we did. So once we are done with start plus 1 call, it's time to return to the, it means you come to here means you are trying to return to the caller. You return to the caller. When you return to the caller, you remove the last element from the list, so that caller will have the same value. So from 1 there are no other possibilities. From 1 you explore the possibility of 2, so there are no other possibilities, so that it's time to return to its caller. So when you are returning to its caller, you need to remove the last element. So you remove the last element so that you get the same subset. Now if you closely see, you initiated a backtrack call with index 1, but this backtrack call, once you initiate a backtrack call, right, it will, you initiate a backtrack call for index 1, right, backtrack call for index 1 with empty value with value 1, right? So it works for, it should work for 1 comma 1, it should also work for 1 comma, sorry, 2 comma 1. So that's how it should work, right? So because if you closely see, from index 0 you have seen index 1 value, but again you need to see the possibility of index 2. So when you move on to index 2, blindly what you do, you just add index 2 value, which is 3. I'm here, right? Okay. So from index 0, you have seen the possibilities of index 1. Now it's time to move on to index 2, because you written a for loop inside a method. If you closely see, this is the for loop, right? Starting from given index, it is moving towards n. So if it is starting from index 1 means it has to do for index 1 and 2. So we have seen for index 1, then we need to look for index 2. So when you are looking for index 2, let me move this. Please spend some time today so that things will be more clear. So when you are looking for index 2, what you do first, you add the index 2 value, so which is 1 comma 3, set index 2 you have value 3. Now it's time to initiate a backtrack. If you initiate a backtrack, generally what you do, index plus 1, so 3, and you will pass this 1 comma 3. So obviously it won't execute the for loop. It adds the result, but it won't execute the for loop. It executes the for loop. So simply you will just do the backtrack, right? So from here you will move on to the caller, so remove the last element, so you get again same one. So it means from index 0 you seen all possibilities, so that you move on to the caller, removing the last element, so you will get 1. Now if you see the backtrack call starting for loop, right? So it has completed with index, starting with index 0, then it will start with index 1 again, then same thing. So it will add 2, then it will initiate a backtrack call 2 comma 2, again it will move on to current index 2, then it will add 2 comma 3. So the same flow, hope you get it. Any confusion here, or you get it? Mm. Where when it comes to index 0, how it goes to index 1, right? Because you see, right, this is how, this is what you are doing, right? This is what you are doing, right? So every backtrack call starting with index 0 and empty subset, right, what it is trying to do, it is trying to do for loop, right? Starting with index, starting with I, and this start less than n and start plus plus, right? What it does, first it will call backtrack call with 0 comma empty subset, then it will call backtrack call 1 comma empty subset, then it will call 2 comma empty subset, right? Because this is for loop, right? That's how it works, right? It called 1 0 2. You are looking at this one or this one? Oh, this is for loop, right? Don't get confused. Where is it? This is for loop, right? So it is starting from current index and look for all possibilities with the same result which is acquiring. What you do once you're done with current possibility, and you make sure that you reset the list. Ajay, Akash, did you get it? Banu. Banu, did you get it? That's it. That's it. So I request you to I request you to uh, take pen and paper, do the complete flow. Okay, so the flow is little tricky. So actually the recursive call stack happening something like this. So first you start from 0. So backtrack call initiated with 0. So it is starting from current index to n. So that obviously 0, 1, 2 will be initiated. And when you start with 0, you will move on to the next index. It is starting from so you will initiate a backtrack call for next index. So 1 comma empty subset, so that it's starting from 1 moving on to the n. That's how it move on. Okay. Let's see. Let's see how do you do that. So simply what we are trying to do, so we have a private void. This is our backtrack, and yeah, so you will have an integer array nums, and this is your index, and you have current list. So what I did, I'll just make list of integers result equal new array list. So what is our thing? So what you should do, first you add data to result dot add of new array list of current list. That's it. So once you are done with this adding, then you are trying to start the set of recursive calls from the current index. So start equal current index, start less than nums dot length, and start plus plus. And once you see the possibility, first you update the current list. Okay, so current list dot add of nums of index. Then you initiate a backtrack call. So okay, I will initiate a backtrack call for the next index, so which is going to be start plus 1. So with the same input, start plus 1 and the current list. Once you are done with the backtracking call with the current list, it's time to remove whatever value you added to the current list. That value is always present at last index, so that current list minus 1. That's it. So you're done with generating all the subsets. So what we do, we will just initiate a backtrack call with the given input and the index 0 and empty list. Yeah, it is nums of start. Yeah, if you add nums of index, you will get the same value. It should be nums of start. Thanks. So finally, we will return result. So let me run. That's it. That's it. So now, what is the time complexity here? Tell me what is the time complexity. Tell me what is the time complexity. What are we doing here, please? You can hear me, right? Okay. So what are we doing here? So with index 0, we initiated an empty subset, and Yeah, I don't want to do that. A time complexity remains same, right? If you closely see how many sub problems we are deriving, right? So that is more important. So how many sub problems we are trying to derive? If you closely see, uh, 1, 2, 3, 4, 5, 6, 7, and 8. Oh, sorry. Yeah. So how many sub problems we are trying to derive? 1, 2, 3, 4, 5, 6, 7, 8. These are only the active. When you look at the complete code, these are only the active stack frames which you are going to generate. So the time complexity remains same. So the number of sub problems when there are n, for n input 2 power n are the subsets, so that we are generating all the subsets, so that it means we are generating 2 power n sub problems, so that the time complexity will be 2 power n. But if you closely see, at each sub problem level, we are copying the result into, we are storing the result, current result into the main result object. It means we are copying the complete result into the uh, complete output into the result, so that the size of the input at max is n, so that obviously the time complexity becomes n into 2 power n. Is it clear? Okay, so what is the space complexity? With respect to stack frames, what is the space complexity? With respect to stack frames, what is the space complexity? How many stack frames active at any point in time? Stack frames means you need to think about how many stack frames active at any point in time, right? So generally what you did, so if you closely see, we are starting from 0 with empty subset, right? So that it is trying to initiate. There are three possibilities. It can start from 0, 1, or 2, but first it will start from 0. So when it starts from 0, so it will just add that value, it will just add that zeroth value, then it will move on to next index 1 and 2. It can do 1 and 2, but first it will go on to the 1, so that it will add 1, and 1 comma 2 will be added, then it can move on to 2, then it will be 1, 2, 3. Then there are no possibilities, so that whenever it is returning back, obviously this gets terminated. Then whenever it is returning back, this gets terminated, then it will move here. If you closely see, from 1 to it will move to 2 here, so 1 comma 2. So once there are no possibilities, whenever it is coming here, it gets terminated. So what I'm trying to say is, at any point in time, though you have 2 power n recursive calls, at any point in time, only n stack frames were active. Yes or no? These are the stack frames are active at max, right? At any point in time. By the time you come here, these two will be terminated. By the time you come here, all these stack frames got terminated. So without terminating these stack frames, it cannot come here. Clear, right? Yes or no? No, time complexity will consider. This is about space, right? This is about space. Space means at any point in time how much of space you occupy. For example, you have a land of Hyderabad, but at any point in time, if you occupy only your home space, you cannot say that my space complexity is land of Hyderabad. So your space complexity is your home only. Same thing. So of course, at any, you have assume that you have a land of Hyderabad, you are using at max a particular space, right? So I'm using at max, this is the space at max I use. By the time I come here, this will get terminated, right? So I reuse the same space, right? You get it? So that's why you can't say that time complexity, why it is n into 2 power n. Time complexity means from the start to end how much of time it takes, right? So to execute each and sub problem, it has to execute all the stack frames, right? So that start to end how much of time it is taking, which is talking about time complexity. So the space complexity for stack frames is big O of n, right? Correct? Everyone is clear on it? Yeah, so in the loop, at any point in time, only n stack frames were active, right? Kalyan, Banu, Akash. Okay, so and what is general? We are also storing the result, right? So when you say result, for result we are storing all the possible subproblems, right? So we are storing all the possible subproblems, and there are 2 power n subproblems, and each subproblem can have at max length of n, so that it is n into 2 power n. This is result object. For result object, length is n into 2 power n. Correct, na? Yeah. So for result object, the time complexity is n into 2 power n. Correct? Yes or no, nobody? Don't get confused. Okay. Give me 5 minutes time so that we can solve other problem. So this is subset 1, and let's talk about subset 2. A little change in this code will work for subset 2, so that I don't need to repeat tomorrow. So in subset 1, what they are saying is the solution must not contain duplicate subsets. Return the solution in any order. That's fine. If you closely see in the problem statement, all the numbers in a nums are unique. So in subset 1, all the numbers in nums are unique. But when it comes to subset 2, you will have duplicate elements. So you will have duplicate elements, but you need to return unique subsets. For example, if you closely see, the only change is you will have duplicates within a given subset, but you need to return unique subset. So it means, assume he has given 1 comma 2 comma 2. If you closely see all possible subsets, 1 1 2 and 1 2 2, right, and 1 2. If you see, this is 1 1 2 and this is one more 1 2, and if you start from here, 2 2 2, then again if I start from here, it is 2. So if you closely see, these are the subsets it can generate, and one is empty. If you closely see, there are duplicate subsets in it. So 1 comma 2 repeated, 2 also repeated. So we have to return only unique subsets. These are the unique subsets. Can you try this problem? So if you closely see, these are the subsets we generated. So if you take this input blindly, these are the subsets we can generate, but we need to remove the duplicate subsets. But to do that, you need to do too much research. Better you spend very good time on this problem and try this out. If you can't do it, and I will explain the analogy behind this tomorrow. Okay? Clear? Or do you want me to explain now? Yeah, yeah. Give a try. But this is not easy thing. Don't look at any solution. Try spend very good amount of time. You have to be very clear about you have to be very clear about this recursive stack to solve that. A single line of code will fix that, but you have to be very clear about this recursive stack. That's it. Okay. So thanks for your time. Generally, what will happen? Let me stop the